Okay, so this material gives us an educational look at animal nutrition. Basically how humans, ruminants, even amoebas ingest and digest food.
Yeah, it's a solid overview, technically quite sound. But I think we can jump straight into the first big opportunity, which is really about grabbing the reader right from the start, that opening section, where it defines the basic problem, turning complex food into stuff the body can actually use. It sort of misses a chance to really hook the reader, to make it feel urgent or dramatic.
Right, I see that. It talks about digestion as the breakdown of complex components into simpler substances, which is accurate, sure, but it comes after reminding us about food components, photosynthesis, things the reader probably already knows. It feels a little like warming up exercises before the main event.
Exactly. Like warming up. It's that typical textbook approach, isn't it? It explains what digestion is, but not really why it's such a big deal, biologically speaking. We know this audience is sharp. They understand the basics. The start needs to feel more like a revelation, not just a review. Why is this process so fundamentally challenging?
So the weakness is that it defines the process before it really shows us how amazing or difficult it is. We're told the definition, but we don't feel the stakes yet.
Precisely. So the suggestion is, instead of easing in with definitions and prior knowledge, why not kick things off with something really vivid? A striking example that shows the sheer biological effort involved. Something that immediately tells the reader why this whole process is so complex and fascinating.
Okay, hitting them with the wow factor early on. That makes sense to avoid that slow start. But what kind of example? Is there something already in the text we could pull forward effectively?
There is, and it's wonderfully weird. Later on, in section 2.1, there's that amazing fact about the starfish. Imagine starting the whole thing there. Not with carbs, but with the starfish opening a shell, and then this is the kicker. It pops its stomach out through its mouth to eat the animal inside, then pulls it back in.
Whoa, okay, that's definitely dramatic.
It is, and it instantly shows how life comes up with these sometimes bizarre, extreme solutions for this basic need. It grabs you, right? It makes digestion feel like this incredible biological drama, not just a mechanical process.
It certainly does. But is there a risk, maybe, that starting with something so specific, so alien, like the starfish, might feel a bit jarring? How do we connect that shock value back to the core mechanics, especially for humans that follow?
That's a fair point. If the starfish feels too out there, the alternative is to lean right into the chemical problem itself, which is central anyway. The text mentions complex things like carbohydrates cannot be utilized as such. We could start there. Contrast that immediately with the goal, the simple sugars, the glucose, that the body can use, which comes up later in assimilation.
Ah, okay. So setting up the chemical puzzle right away.
Or these big unusable molecules, and an after, the simple fuel the body needs. Frame it right in the first paragraph. That creates this inherent tension, this mission that applies to everything from the amoeba to the human to the cow. They're all solving the same chemical challenge, just with different toolkits. It gives the whole chapter immediate intellectual stakes.
Okay, that makes sense. And that leads us nicely into the main part about the human digestive system. Now, the way the material walks us through the alimentary canal, mouth, esophagus, stomach, and so on, down to the anus, it's logical, it follows the path of food, but I think there's a chance here to weave things together more tightly. Specifically, the connection between the organs themselves and the glands, salivary, liver, pancreas, that are doing the heavy lifting chemically.
Digestive juices, the salivary glands, the liver with its bile, the pancreas, they sometimes feel a bit like side notes. Their jobs are explained, but maybe not as integral parts of this coordinated chemical attack.
I felt that too. Reading it, it was a bit like checking off boxes. Here's the organ, here's its function. But the secretions, which are really driving the whole breakdown, they almost felt secondary to the tube itself, which is sort of backward, isn't it? We could maybe better connect the structure to the action.
Right. Is the link between the physical structure and the chemical job really driven home? I think we can strengthen that. The suggestion here is to frame the journey through the digestive tract less like just an anatomical tour and more like a chemical relay race. Really emphasize how the different secretions build on each other, tackling specific food components, carbs here, proteins there, fats later, in these carefully controlled, changing environments. It's about telling the chemical story that's happening inside the anatomy.
Turning it from a list of places into a dynamic process. I like that. But how do we do that without slowing things down too much, if we keep pausing the anatomical tour to explain the chemistry?
We can use the interesting bits already in the text as key moments. Take that great story about Alexis St. Martin and Dr. Beaumont, the guy with the hole in his stomach. Instead of it just being a historical anecdote, make it a real turning point when discussing the stomach.
Use the history to make a structural point?
Exactly. Use Beaumont's discovery that the stomach wasn't just passively holding food, it was actively churning it and secreting acid and mucus. Use that to show why the stomach is the way it is. It's a specialized chemical reactor. It's acidic. It targets proteins. It's a totally different environment than the mouth. That historical moment demonstrates the first big shift in the chemical strategy.
Okay, I see. That really elevates the Beaumont story. It's not just a fun fact. It explains the stomach's unique role as this, well, acid bath designed for a specific job.
And then you do something similar later when you get to the small intestine. Really underscore that this is the grand central station. This is the convergence point where everything comes together. It gets bile from the liver to handle the fats and pancreatic juice that hits all three major food types: carbs, fats, and proteins.
Highlighting that convergence is crucial. It makes sense of why the small intestine is so long and complex. It's not just another tube. It's the main arena where all the chemical work gets finished, breaking everything down into those simple, absorbable units: glucose, fatty acids, amino acids. Framing it that way turns the list of organs into a really logical, coordinated chemical campaign.
Okay, now let's look towards the end at the sections on ruminants and the amoeba.
Right, these parts cover how grass eaters like cows digest cellulose using the rumen and rumination, and how a single-celled amoeba manages with pseudopods and a food vacuole. The details are there, they're accurate, but maybe the overall punch isn't quite landing.
Yeah, the descriptions of the ruminant system and the amoeba are solid on their own, but I think they could be used much more powerfully to give real perspective on digestion across the board. Evolution, efficiency, different strategies.
Currently, they feel a bit like separate case studies tacked on at the end. Here's the cow, here's the amoeba, which is interesting, but it kind of dilutes the chance to draw a really strong contrast between extreme complexity on one hand and fundamental simplicity on the other. They don't feel fully connected back to the human system as comparative benchmarks.
That's a good way to put it. The weakness is the reader might finish up without really getting that big picture. So what? Why did we learn about the cow's 4 stomachs or the amoeba's little vacuole? What does it tell us overall?
Exactly. We need to show how these incredibly different systems are actually just 2 different answers, 2 evolutionary paths to solve the exact same basic problem: get energy from food. That would really boost the significance of the ending.
So, the suggestion is to explicitly frame these 2 examples, the super-specialized ruminant and the minimalist amoeba, as contrasting bookends to the human system. Humans are kind of the middle ground, maybe. These show the extremes.
Okay, using them as explicit comparison points. What specific contrasts, using the facts already there, would really drive that home?
Well, you directly compare the ruminant's incredibly complex setup, the huge rumen, the whole cud chewing process, needing specialized bacteria just to break down tough cellulose. Compare that directly with the amoeba's beautiful, elegant simplicity.
It's the ultimate contrast: massive specialization versus bare-bones necessity.
Precisely. Emphasize that the tiny amoeba achieves the same core goal: take in food, break it down, get energy, using just its false feet or pseudopodia to grab food, trapping it in a single food vacuole, and squirting in some digestive juices. It's minimal, but it works. It's a complete system in miniature.
That comparison really highlights the evolutionary trade-offs, doesn't it? Extreme adaptation for a difficult diet versus the most basic universal approach.
And then use those structural differences: the long, winding, multi-gland human gut, the multi-stage, bacteria-filled fermentation vat of the ruminant, versus the single, simple food vacuole in the amoeba. Use those differences to hammer home that so what. show that while the goal is the same for all life, the method is shaped entirely by what you eat and where you live. It turns those final sections from just interesting examples into a really profound concluding statement about life's diversity and ingenuity.
Okay, this has been really useful. Looking at the material through these lenses definitely highlights some areas for enhancement. So just to recap the main thoughts.
We talked about 3 key areas. First, really grabbing the reader from the outset. Elevate the core essence by redefining the stakes, maybe using that startling starfish example, or setting up the chemical challenge immediately to create a strong narrative hook. Don't just define, dramatize.
Second, integrating the structure and flow better, moving beyond just listing the parts of the digestive tract. We need to weave the glands and their secretions into the narrative, showing the alimentary canal as this coordinated chemical relay, using things like the Beaumont story to mark those key chemical shifts in the environment.
Exactly. Make it a chemical journey, not just an anatomical map. And finally, leveraging those comparative examples, the ruminant and the amoeba, much more effectively. Don't just present them as separate cases.
Right, use them as powerful bookends to the human system. Contrast the extreme complexity needed for cellulose with the minimalist efficiency of the single cell. That comparison really drives home the broader evolutionary significance.
So the actionable steps are: take another look at that introduction. Can you make it more immediately compelling? Integrate the gland functions more deeply into the flow of the digestive tract narrative, and sharpen that final comparison between the ruminant and amoeba structures to really land the so what about digestive diversity.
Makes sense. Review the intro for impact, weave the chemistry into the anatomy narrative, and use the cow and amoeba for a stronger comparative finish.
And once those refinements are made, feel free to send the updated material back our way. We'd be happy to take another look.